Okay, here's question 2 about ice hockey. So I've got a bit of a story here that I'll let you read if you want to pause it and read. But the question is asking us to describe the key features of this distribution. So the first thing that we'll notice here is that all of the results on our graph are discrete whole numbers. So I'll say that it is a discrete distribution. Okay, so we've got a discrete distribution. What else is it doing? Well, because it's measuring the number of goals per game, that's a rate. So I'll say it measures a rate, which is the number of goals per game. Okay, what else? Well, the graph has a skew. It appears to skew out to the right, so we'll make a note of that. So it skews to the right. And that's a good few sort of observations there. Now the other thing it wants us to do is obtain an estimate for the mean. So in order to do that, we're going to take each number and multiply it by its relative probability. So the first one there is 0, so we've got 0 times 0.06 plus 1 is 0.18, so plus 1 times 0.18 plus 2 times, and 2 has a probability of, it would appear 0.25, and 3 has a probability of 0.23, plus 4 times 0.16, plus 5 times 0.1, plus 6 times 0.02. So if we put those all into our calculator and add them up, we get 2.63, and so that gives us a mean. Okay. Now there's one other central tendency that we can measure, and that's the mode. So we should probably make a note of the mode as well. So up here we'll just also say that the mode is 2. Okay, and that's our mean there. Okay, I think we'll just continue with this question. So now it says, after 30 minutes in a hockey game, the team has scored no goals. Using your answer in part A and an appropriate distribution to model this calculation, calculate the probability of a team scoring at least 2 goals by the end of the game. In your answer, justify your choice of distribution. Well, I'm going to use the Poisson distribution, so we'll just make a note of that. So using Poisson, and then I'll explain why. So using Poisson distribution. Okay, so using the Poisson, well, we just worked out before that our rate is 2.63, but in this question it's across 30 minutes, so we're going to divide that by 2 to get our rate for 30 minutes, so that gives us 1.315, and so we're going to work out the probability, or that question is asking us to work out the probability that x is greater than or equal to 2. And so another way of thinking about this is that's probability of 1 minus the probability of x being less than or equal to 1. And that part we can work out on our calculator. So I'll bring up our calculator, and so we'll go into stats mode, and we want the Poisson distribution. Oops. So distribution and Poisson, and we'll do PCD, and we'll do variable. Alright, so our x was 1 and our rate was 1.315, and that gives us 0.2615. So we'll go back to OneNote. So that gives us 1 minus 0.2615 6215. And putting that into our calculator, we get 0.3785. Alright, now I want to talk about why we chose Poisson and what assumptions that we made. And so the number of goals were discrete, so that's one reason, and Poisson is discrete. So the number of goals scored in a game is discrete. Okay, so basically what I'm saying there is you can't have a part goal scored. 2 goals cannot be scored at the same time. So 2 goals cannot be scored at the same time, and that is a requirement for Poisson, that your events cannot occur at the same time. Okay, scoring each goal is also independent, so we'll say that scoring each goal is independent of each other. Independent of each other goal. And that's actually an assumption. Okay, we're assuming that that is the case. And the reason why we have to assume that, or what that means, is that if you score 1 goal, your chances of scoring another goal hasn't changed. Now that's an assumption because probably in sport, if you score a goal, that might motivate you, and you might end up getting another goal, or be more probable to get another goal. Or conversely, it might make the other team more hungry to score goals to catch back up again. So that's an interesting one, but that's an assumption that we'll make here. We're also assuming that there's no upper limit to the number of goals that can be scored. So there is no upper limit to the number of goals that can be scored. Okay, and yeah, that's also an assumption. In reality, you could have a limit, but in this case, we'll just assume that there is no upper limit, and we'll leave it there.